Hi, I'm Ruchi Mishra, student of ME Software Engineering, Thapar University, Patiala. My research area is service-oriented architecture and web services, and I'm proposing a framework for web services security in SOA. Introduction: we can say that web services are a web API identified by URIs and integrated with the applications using XML, where service-oriented architecture is an archetypal based on the discrete functional units called services, where services expose the functionality and business functions. It promotes abstraction, loosely coupling, and distribution of services. Web services are integrated as application using XMLs, and they are accessed over web infrastructure and protocols. Web services technology, we have simple object access protocol that is used to exchange messages between service consumer and service provider. WSDL, that is a web service definition language. UDDI is a registry where the services are stored and invoked by the service consumer. REST is a protocol that is based on the HTTP protocol and can support XML and WSFIP is a framework and Java API to invoke the web services. We have web services security standards which are guidelined by the W3C or OSIS or JCP organization that work for web services security. These can be like WS policy, WS security, WS trust, WS secure conversion, WS reliable messaging, WS atomic transaction, and transport layer and access control layer. There are few frameworks which are proposed by the authors working on the research area of WS security, and the first one is the proposed by Interest Web Services framework by organization Interest, and the security framework again XML attacks, and we have a security framework against WSDL attacks. One of the author also proposed a RESTful services stack just like the web services SOAP stack. Another author has proposed a model-driven security architecture that is implemented on an e-government project. Then we have a framework against denial of service attack. Web services specification. There are few specifications that are published by the authors working on them. That is, first one is like XML rewriting attacks and to secure the SOAP account header from XML rewriting using few of the elements that can be considered at the consumer side. We have a specifications to ensure message integrity and against the fault tolerance. The objectives and problem statement of this analysis is to get a security framework for an integrated web services based SOA environment. The objectives are to get the authentication through web username token, secure connection through digital certificate, message integrity through digital signatures, message confidentiality, XML encryption. The proposed work is a certificate-based message protection and username token which combines the message level and transport level security to ensure that communicated parties and the link are secured that can be tracked by the WSDL attacks. It uses a WSM policies that addresses SOA-based web services security and declares and web services policies that can be implemented on the service consumer and service provider side. It provides configurable agents to enforce security policies. The deployment architecture is like that key stores and stores the digital certificate and public-private key of provider. The wallet contains username token and the secured WSDLs are secured with the policies. These three things are done at all the intermediaries and service consumer and service provider. There is one more point that key stores of the proxies contain the digital certificate and public key of the provider, and service consumer key store contains the public key of proxy server. The implementation of security framework is done at the edge app services, that is a service provider. decorator services, which are intermediaries involved, and client server, which acts as service consumer. There are few tools that are used for implementation like artifact generator, a retail SOA enabler, and a SIT tool. SIT tools mimic the Edge app application, and JSIT is used as service provider in the framework. The deployments and illustration at the high level can be first, all the communicating parties should be listening only to the HTTP, not to the HTTPS, and then the username token and key pairs and certificates are generated. The web services and the application service are configured with these policies. Then we set the decorator service deployment, and decorators are packaged with the secured visitors which are downloaded from the Edge application, generated username token, certificates and key pairs for the decorator service, and it further imports and wraps Edge app keys store. At the service consumer side, to get the handshake happen, it first accesses the secured decorators. It generates username token of its own and key pairs and imports and wrap decorator services. Verification and implementation. To verify this, we have key store configured at the domain level, and we check at the service provider end, and we check the secured wisdom that whether the policies are implemented and embedded or not. For testing of this framework, we have used OSP console and SOAP UI. At the OSP side, we provide key store recipient alias, CSF alias, and that promotes the security parameters configured, and it gives the response. And at this for the SOAP UI, we hit the message with username token on the HTTPS protocol, and we get the response as encrypted, and digital certificate is imported in the header. It can be concluded that a solution for web services security is provided, and we have achieved the web services aspects as in the objectives. A cluster is used to improve performance and reports. The further enhancement is to improve performance and to get the QoS parameters and to improve the processing time and reduce the latency involved. Thank you.